Hello everyone, I'm just going to go through the solution that I had for the homework 3. So the homework 3 asks us to create the producer and consumer problem, or solve the producer and consumer problem with the buffer of 15 slots, but this time using only one semaphore. So what I'm doing here, I am just creating a new text with an initial count of 0, and then I create producer and consumer and resume them. But the point here is that the producer has a higher priority than the consumer. So essentially, the producer, as long as it wants to run, it will keep the CPU. And the idea is, once I create 15 values, or once I fill up the buffer within the producer, I will, call wait on the mutex so that the consumer starts running. And then once the consumer finishes consuming the values, I will signal the mutex so that the consumer goes ahead and starts filling up the buffer again. So here's the producer function. So I just simply, print this to see when I start this for loop again. So this is just a producer 2, to see when it is running. And once I fill up the buffer, so this loop is, goes from 0 to buffer size. Once the buffer is filled, I call wait on mutex. And since it's initialized to 0, the wait will simply, put the producer in semaphore queue. And at that point, the consumer will start running. So the consumer does the opposite. Again, I print the name of the function here, and then I go through this for loop. And I know that no context switch will happen to the producer because it's on semaphore. It's not ready. It's not in ready state. It's waiting on a semaphore. So if I don't signal the producer here somewhere in my consumer, I know that it won't get the CPU. So that's why I can go through the loop and print all of the values, and then once I'm done and I print once the consumer is done with consuming all of the values in the buffer, it signals the mutex. And since this is a critical point here also, since there's a process, the producer, waiting on this mutex, and it has a higher priority than consumer, the signal will result in a context switch. So we will go back to the producer, and the producer will continue from where it left off, which is the wait call. The wait call will return, then we'll see another producer. It will print the values and call wait again. It will block, and we will go to the consumer, and we'll keep doing the same thing. The consumer will consume the buffer and then signal the mutex, and we'll go back to the producer. So that way, using one semaphore, I can manage the context switches and ensure that the context switch takes place exactly when we want it, meaning after the buffer is filled up with values, and within the consumer, after the buffer, all of the values within the buffer have been consumed. So I'm just gonna load this in my Xenu and see if it does what we want it to do. So now we should be able to see that the producer runs and produces 15 values. At that point, the context switch takes place. The consumer starts running, it consumes 15 values, and another context switch takes place back to the producer. Okay. Let's see where it starts here. So now, first, the producer started, and it produced 15 values. Let's go up to where it started. So here what we see is the producer started and it produced 15 values, and then a context switch happened and consumer started running. The consumer prints 15 values, or 14. It should have been it should have printed at 15 as well. So so there's an issue with my implementation, but probably it's the loop index. If you change the loop index, it will probably just print it 15 as well. And then we go back to producer, and it produces 15 values, and right after that we go back to the consumer, and it prints from 16 to 30 the next 15 values, and then we go back to producer and consumer, and that way, like, you know, this way we can manage the context switches using only one semaphore.